Okay, let's dive right into this. Welcome to this documentary-style explainer. Today, we're tracing the absolutely fascinating 30-year evolution of Boston Dynamics. We're going to map out exactly how a tiny university research lab basically transformed into the dead center of the modern robotics space race. It is a wild story. We're talking engineering marvels, some pretty chaotic corporate ownership, and an overarching drive to literally alter the future of human labor. To really grasp why this company is such a big deal right now, we've got to anchor everything on this one core concept: physical AI. Look, for years, artificial intelligence has kind of been trapped behind a screen, right? Processing data, writing text, maybe generating some cool images. But physical AI? That represents the ultimate stakes of the modern tech race. It's the idea that the true massive economic value is going to come from systems that can actually walk onto a factory floor and physically turn a wrench. Part 1. Origins, the Leg Laboratory. Now, to see where we're going, we actually have to jump way back to 1992. That's when founders Mark Reibert, Nancy Cornelius, and Robert Plater spun Boston Dynamics right out of MIT. At the time, if you looked at an industrial robot, it was basically a massive, blind arm bolted to the floor, blindly repeating the exact same rigid motions over and over. But this team, they wanted to crack an almost impossible code: dynamic, biologically inspired agility. They wanted to build machines that could balance, adjust, and navigate through our messy, unpredictable world, just like animals do. But funding that kind of bleeding-edge research? Well, it meant taking on military contracts. The biggest one came from DARPA in 2005, giving birth to Big Dog. Just look at these specs. This robotic pack mule was designed to carry 340 pounds up a steep 35-degree incline. To put that into perspective, that's like carrying two full-grown adults up a massive hill. It was a brilliant proof of concept for the physics of rough terrain robotics, but there was a catch. It was ultimately shelved because its gas-powered hydraulic engine was literally so loud it would instantly give away troops' positions. Incredible tech, just not a deployable product. Part 2. The struggle to commercialize. So that early military phase leads us straight into what you could call their corporate purgatory years. It was a seriously chaotic journey. I mean, they had arguably the most incredible robotic technology on the entire planet, but they struggled immensely to find an actual commercial market. They were scooped up by Google's Moonshot division in 2013, but they never really clicked with Google's software-first culture. So then they were sold off to the Japanese conglomerate SoftBank in 2017, before bouncing yet again to the South Korean automaker Hyundai in 2021. Honestly, they were a brilliant research lab just desperately searching for a business model. And that 2021 Hyundai acquisition, that's really where the entire story flips. Hyundai grabbed an 80% controlling stake from SoftBank for $880 million. That deal valued the whole robotics firm at a staggering $1.1 billion. That's billion with a B. And this wasn't just some vanity purchase for Hyundai. This massive cash injection was the true financial kickoff for Boston Dynamics to finally pivot toward real commercial viability. Part 3. Enter the Hyundai era. Under Hyundai, the game completely changed. They aggressively shifted focus away from just making those viral YouTube videos of robots doing backflips and aimed squarely at enterprise warehouse automation. Hyundai's executive chair looked at Boston Dynamics and didn't see a toy. He saw a critical puzzle piece for a fully automated supply chain. They called it their smart mobility vision, basically moving Hyundai beyond just making cars. The jaw-dropping long-term goal here? Producing 30,000 humanoid robots annually to integrate directly into smart factories and global logistics chains. But behind all that ambition, there's actually a very high-stakes business tension playing out. See, when Hyundai bought that 80% stake, SoftBank kept 20%, and they attached a specific put option agreement to it. Because Boston Dynamics didn't go public with an IPO by June 2025, that option was triggered. So now Hyundai has to figure out how to buy out SoftBank's remaining shares directly, which is a massive immediate financial hurdle for the automaker. So why are they going through all this trouble? Well, analysts at Cabot Securities projected the upper-end valuation of the broader physical AI market over the coming decades. And the number is absolutely staggering: $100 trillion. Trillion. That context shows exactly why this whole corporate shuffle has such insanely high stakes. Honestly, whoever controls the future of physical labor, well, they kind of control the whole economy.
Part 4. The Electric Atlas Revolution.
To actually capture a slice of that market, the hardware itself had to evolve. This timeline maps an 11-year engineering journey for their flagship bipedal robot, Atlas. We start way back with the 2013 DARPA prototype, this bulky 330-pound machine literally tethered to a power cord. By 2016, we get the untethered high-definition version. And then, boom, April 2024, they ditched the hydraulics entirely and revealed a super sleek, mass production-ready, all-electric commercial Atlas worker. Now, to make that electric leap, they needed a major engineering breakthrough called quasi-direct drive, or QDD. Sounds super technical, but essentially, by pairing low-ratio gearboxes with high-torque motors, they created joints that are highly backdrivable. In everyday terms, it means the new Atlas isn't totally rigid. It can physically feel and safely interact with external forces. So if a human worker bumps into it, the robot sort of gives way naturally, without relying on expensive, fragile sensors that would easily snap on a rough factory floor. And the pivot to electric makes total sense when you break it down. Look, hydraulic systems are powerful, sure, but they're rigid, ridiculously loud, prone to oil leaks, and honestly a complete nightmare to maintain. Electric actuation, on the other hand, it's quiet, it's energy efficient, and incredibly precise. Plus, it allows for true 360-degree joint rotation. The new Atlas doesn't just copy human constraints. It can twist its waist, hips, and neck in a complete circle, just moving in whatever way is physically most efficient to get the job done. But hey, a great physical body is totally useless without a brain to match, right? So in early 2026, Boston Dynamics partnered up with Google DeepMind to integrate Gemini Robotics AI directly into Atlas. This is huge. It bridges the gap between raw physical agility and cognitive embodied AI. Basically, it brings vision, language, action reasoning to the factory floor. Atlas can now look at a messy pile of parts, understand a spoken verbal command, and completely reason through a complex multi-step assembly task, totally on its own. Part 5. Spot and stretch at work. While Atlas is definitely the future, let's take a look at the robots that are out there actively generating revenue in the real world today. First up is Spot, which you probably know as the famous robot dog. But in the real world, it's actually a highly advanced automated safety inspector. Starting at around a $75,000 base price, massive companies like DHL and Chevron deploy Spot to autonomously patrol their facilities. It uses thermal imaging to catch machinery before it overheats, acoustic sensors to literally listen for invisible air leaks, and AI visual checks to make sure fire extinguishers are exactly where they should be. It's catching massive problems long before they cause expensive downtime. Then we have Stretch. This is their logistics powerhouse. Listen, unloading floor-loaded freight from the back of a boiling hot shipping container is arguably one of the hardest, most physically grueling jobs in any warehouse. Stretch is purpose-built to take over that exact nightmare task. Using a custom vacuum gripper and some seriously advanced computer vision, Stretch can effortlessly move up to 1,000 cases per hour, all day long. It's quite literally saving human workers from debilitating repetitive strain injuries. Part 6. The future of physical AI. As we look out into the long-term impact of all this, the ultimate vision isn't just one cool robot doing one specific job. We're talking about a multi-robot ecosystem. Imagine a facility where Spot is roaming the perimeter doing inspections, Stretch is on the docks unloading the incoming trucks, and a whole fleet of electric Atlas humanoids is running the assembly lines. In this world, human workers elevate from doing manual labor to being system supervisors. The physical products? They're barely ever touched by human hands during their entire life cycle. Which brings us to a really provocative question. With Boston Dynamics proving day in and day out that physical AI is absolutely no longer science fiction, what happens when highly automated lights-out warehouses, facilities that literally don't even need the lights turned on because there's not a single human inside, become the standard reality by 2030? It is going to be a massive shift in how the whole world works, and the stakes of this robotics race have never, ever been higher. Thanks so much for joining me for this explainer, and definitely keep an eye out for what comes next.